All right. I think that this is a very valuable pair of questions. We were able to compute the derivative without too much work using the limit definition. Now I would like to graph both the function and its derivative on the same axes. So let's first graph f of x. Okay. F of x is the function x cubed minus x, which we could factor as x times x squared minus 1, which factors further as x times x plus 1 times x minus 1. It has a y-intercept of 0, and it has x-intercepts at -1, 0, and -1. Okay. The graph of this function looks something like this. Oops. Good enough. Okay. To be honest, I can't remember exactly how high those peaks are, but let's not worry about that. Okay. There's the graph of this function. Now we said that its derivative, we just did some work and we found out that its derivative was the function 3x squared minus 1. What does the graph of that look like? It's a parabola, right? It's a happy parabola because it opens upwards. Right? It's got a y-intercept at the order pair 0, -1. Does everyone see that? It's got a y-intercept at the order pair 0, -1. If I wanted to find the zeros, I would set f prime of x equal to 0. That would happen when 3x squared minus 1 equals 0. That happens when x squared is equal to 1/3, or when x is equal to plus or minus 1 over the square root of 3. I did that fast. All I did was solve an equation, folks. 1 over the square root of 3 is approximately 0.57. So that would be right about here and right about here. So now we know it's a parabola. We can go ahead and finish graphing it roughly. We get something like this. Any questions up to this point?
-1 or 0, -1.
Yeah, so I was looking for the y-intercept of f prime of x. The y-intercept is an ordered pair that looks like 0, something. So what did I do? Because that's what puts me on a y-axis, right? So I just plug 0 into the function. I said, what's f prime of 0? Well, it's 3 times 0 squared minus 1, which gives me -1, so that's the ordered pair 0, -1. Great question.
I'm just a little bit confused at the, like, not the blue part, but like at the when we first had the function x cubed minus x.
Yeah, great question. So we're right here, okay? So what did I do? I went ahead and factored it.
Okay.
Why did I factor it? Because when a function's in factored form, it's easy to identify its zeros. So when I set f of x equal to 0, that happens when x times x plus 1 times x minus 1 equals 0, right? So that happens when either x equals 0 or x plus 1 equals 0 or x minus 1 equals 0. I just applied something called the zero product property, which is what allows you to take nonlinear equations and break them down to linear equations. So that gave me the 3 x-intercepts of this function. Great question. And then just because this was a college algebra technique, the leading coefficient was positive, and it's an odd function, which means it comes in through the bottom and goes out through the top as you go from, I'm confused, left to right. Yeah. Great question. Folks, I just spent a lot of time on this, so I want to make sure we all understood how we got the graph. Because now I want to interpret these graphs. Okay? Now, I've mentioned this maybe once before in this class. Going forward, the pronoun it should be avoided. Okay? You should avoid the pronoun it. What you do not want to say is, when it's positive, it's increasing. Because nobody will know what you're talking about, including yourself. I promise. You will eventually confuse yourself. Okay? The original function is colored black here. The derivative is colored blue. When the black function is increasing, the blue function returns positive values. When the function is increasing, meaning going uphill, the blue function outputs positive numbers. Because why? If you put slopes of tangent lines on here, what are the slopes of all these tangent lines?
Positive.
They're all positive. So blue should be, which outputs the slope of the tangent line at any given x value, should be returning positive numbers. When black is decreasing, what are the slopes of all those tangent lines? They're all negative. What is the sign on blue? Negative. Now, be very careful. Sometimes when blue is negative, it's decreasing, and sometimes when blue is negative, it's increasing. But as I'm asking these questions, I'm not saying is blue increasing or decreasing, I'm saying is black increasing or decreasing, and if so, what is the sign on blue? Okay? It's very important you learn to keep track of what information you gain from the original function, what information you gain from the function's derivative, and how those are paired together. Okay? So we could even summarize that, and I'll do that right somewhere over here. When f is increasing, f prime is positive. Okay, that's a nice little summary. When f is decreasing, f prime is negative. Okay. What you don't want to say, one more time, what you don't want to say is when it's increasing, it's positive, because you're going to confuse yourself. You want to say when the function is increasing, the derivative is positive. Or when the derivative is negative, the function is decreasing. Okay? Notice too that there are 2 points, let's give them their own special color. There are 2 points on the original function where we have horizontal tangent lines. Notice that those 2 points correspond precisely to where blue changes from either positive to negative or from negative to positive. Or at least, maybe this doesn't necessarily have to do that. It at least touches the x-axis. Where black has horizontal tangent lines, blue touches the x-axis. Because the slope of a horizontal line is what? 0. Okay? I highly recommend that you spend 10 minutes getting to know these graphs when you get home tonight. Before you go to sleep, spend 10 minutes looking at these graphs. Talk about it the way I just did. Okay? See if you can make sense of that, because it's going to pay big dividends come the next 2 chapters. All right.